Okay, welcome everyone to this webinar, Rethinking Web App Security. I'm Jonas Igbaum, and I'm joined today with my colleague, Gary Archer. Hello, Gary. Today, we're going to discuss the latest trends and recommendations around web app security. There's a lot of solutions and approaches out there, and there's a lot of confusion in this, typically since we see APIs implement backend security. And we are going to cover and take a look at a little bit more to understand web security and sort of what responsibilities of security goes where. And so we're going to look at how modern APIs work and how web front ends best interact with these APIs.
Yeah. Thanks, Jonas. So I think, yeah, so these days organizations develop APIs, and there are multiple types of clients. Of course, we've got web applications, but there's also mobile, business partners, even AI agents we're seeing. And all of these different types of API clients integrate with APIs and need to do so in an optimal way, I guess, so that they get good usability and other qualities. And it's a little bit tricky for web apps because of the best practices in the browser. If I talk about the big picture here, so we're going to talk about some of the intricacies of web and API interactions. And as I say, modern architectures tend to follow an API first approach because APIs are the unit of reuse and they serve multiple clients. And APIs tend to manage the data protection, the access to business resources, and ideally they should grant clients only least privilege and short-lived access, and then allow clients to renew their API message credentials. And hosting is also an important consideration when planning architectures as well. For example, web and API hosting can work differently. Move on. So really, there's a landscape where you need to protect APIs, clients, including web applications, and I also deal with user authentication, user privacy, those kinds of concerns. And really, that's the role of the OAuth 2.0 authorization framework, which provides a lot of solutions for authenticating users and issuing tokens and including user attributes in the tokens, for example. And often the access tokens are a little misunderstood. And so we're going to talk more about the access token today and how APIs can sometimes drive client behaviors using the access token. And in addition to the API side, there's also the client environment. So, if a client runs in a mobile environment or web environment, you need to apply environmental protections. For example, a big concern in the browser is cross-site scripting and coping with that. And as I say, there's some differences for API and client deployments. There's, for example, these days, to get the best web performance, delivering all of your static content to a content delivery network that pushes it all around the globe so that web latency is the same for all users is a common approach. Whereas you can't typically do that with APIs so easily because sometimes APIs are tied to their data and the data needs to stay in certain regions and things. And so API hosting is more complicated generally. So it's worth being aware that you can deploy web and API backends in different ways. So Jonas is going to talk a bit more about the separation.
So we have sort of
yes. I know. Sorry, Jonas. After you.
We have sort of like web applications and APIs, right? But it comes down a little bit to kind of separation of concerns here, right? Who's going to be responsible for what and who's doing what? Gary mentioned OAuth, obviously, which is kind of close to our hearts, but it's more than just, hey, let's put OAuth on this and then we're good to go, or let's get an access token and then we're fine, right? So Um, to deliver sort of an optimal web application security solution here, we need to externalize the API security responsibilities from the web application itself, right? Um, and if you move to the next slide here, I think we have a couple of sort of modern web application security best practices, we can call it, where implementing the OAuth 2 for browser-based applications, which is what would we call it? A profile of OAuth. It's essentially the de facto standard or document for web application security in OAuth. It it describes the backend for front end pattern, which we will discuss and talk more about a little bit later here. Um, but one of the huge parts, and Gary, you already sort of alluded to it, that is a problem here, especially for modern web applications, is protecting against cross-site scripting attacks. Like the the browser is pretty vulnerable to that. It's a pretty hostile environment, right? So we need to do what we can to protect against that, but also in our world and in that like access token world, protect the access token. I think there's a lot of misinformation out there in terms of how this is handled. The access token is not always treated in a way where it's safeguarded enough in modern web applications. So we need to use hardened cookies as the transportation mechanism for these tokens, and deliver them in a secure way to the APIs.
Because one of the big concerns in that document, Jonas, is the interception of tokens, etc., and sending them out of the browser and those types of attacks. And with a cookie, because JavaScript code cannot access it, it's considered more secure. I think a lot of people understand that these days, but
Exactly.
I think
Yeah,
there's some
uh,
intricacies that people understand less. So
definitely. I actually, it's interesting. I did a presentation on that topic, and we've done some other webinars on the token handler pattern, where I had one slide in that presentation. It was 2 lines of code that could export um, all of the information from sort of the local storage of a single page application, right? And if you store the token there, that's it. You can get the token out. And straight up access tokens are comparable to cash, if you want to look at it that way, right? If I can get it, I can use it. So yeah, there are though some kind of built-in defenses and mechanisms, right? As a whole for web applications. And we mentioned on the previous slide here, sort of secure cookies as being the transportation mechanism. So same site cookies, it is a way to prevent malicious sites from sending cookies to your API, so we can control that the cookies are sent from essentially the same domain, right? And CORS is another built-in mechanism to prevent malicious origins from sending your cookies to your APIs. And now we're talking about cookies as the transportation mechanism for our access tokens here, right? And then content security policies. This is I think a critical one, because this is where we start getting into controls around like which JavaScript code and things like that we can execute and make sure and tighten the security around where JavaScript can execute from, so that we can control that. We might have our own JavaScripts and we need them to execute, but we don't want malicious actors to inject their own code here, right?
yeah, and I think one important point about the cookies that you touched on there, Jonas, is probably the requirement is that uh, the browser's exact origin, only the browser's exact origin can use the cookies, and only the exact cookie host can accept it. And um, they're not always the same either. Sometimes the web application can run in a browser, and the cookie can be issued by an API. So
Right.
as long as that you restrict cookies correctly, that's the big requirement, really, I think, to prevent some of these attacks.
For sure. So the flow kind of looks something like this. We have a modern web application probably gets data from um, um, some web host, and this is where we then see the um, cross-site scripting risk and attack vector. Uh, cookie cookie transports the access token here. Also, you know, a gateway in front of the APIs here is sort of a de facto and default mode in this day and age, right? Where we host our APIs, and it should be very important here to look at the what the access token actually looks like, and we can talk about it as what the cookie looks like too. But yeah, I think there's a maybe not necessarily a one-to-one mapping, but there's definitely an argument for cookie time to live and short-lived, but also the same with the access token, and they go hand in hand, right? But you mentioned earlier too, sort of the least privilege approach too, right? We don't want access tokens and cookies that essentially work for everything, right? With broad access, there should be scoped with privileges in such a way that I can get the information from the APIs that I need, and it's short-lived. So if we lose this token, we've also minimized the attack vector from that, right? So no tokens that are or cookies that are sort of have a time to live for several days and things like that.
Yeah. And probably core behaviors of OAuth 2.0, I think, short-lived and least privileged API credentials. And I think some of the older cookie solutions maybe dealt less well with that, but OAuth 2.0 established these principles. So even if you use cookies to send access tokens, ideally those privileges should remain valid, because there is I suppose there are other attack vectors in addition to cross-site scripting, like the hacker guy who's, if he can and he can get hold of cookies or tokens, he can typically replay them as a bearer credential. That's like cache, as you said.
Right.
So generally, whenever you use OAuth, short-lived and least privileges are highly recommended to protect against these threats.
Yep. So if we now look at this sort of security responsibilities, then we kind of, like I mentioned earlier, separation of concerns here. So the web developer's security responsibility should come down to sort of applying cross-site scripting attack prevention to do what they can to protect against that, and followed sort of OWASP and Mozilla resources for best practices and look at what the top vulnerabilities and things of that nature are there. I mean, unfortunately, we still see a lot of OWASP listed things that it just keeps happening over and over and over again. So there's some, I wouldn't necessarily say super easy things, but there's a clear sort of list to follow, I would say. Again, applying strict CSP to the web host, and limit the impact of like cross-site scripting exploits can that can cause session writing where yeah
Yeah. So I mean,
we,
at
we
some
use
point,
the cookies.
yeah, at some point, perhaps with all of these JavaScript possible supply chain attacks and things, you could get an XSS exploit. So therefore, these session writing means it's contained within the browser. You can't send your data or tokens or
Right.
anything, cookies to an external host.
But the bottom line there is that we have kind of narrowed down the scope for the web developer to have a set of clear responsibilities to deal with these things within the web application. They don't have to, and they should not sort of deal with the API security on the back end, which is the responsibility of someone else, right? So we have kind of narrowed the scope of what they should be focusing on and what they need to know, do, and deal with, right?
Yeah. And that's a very good point, actually, because I think that a lot of the smart web developers I've worked with, they're very much on top of XSS and CSP stuff, but they probably don't understand the subtleties of cores and cookies and stuff so much, because that's more of a back-end responsibility. So,
Right.
we're going to talk about, like I say, we're talking about an API first architecture. And what a lot of people don't quite understand about OAuth is that the API can actually drive the front end to some extent. So there are a couple of mechanisms that APIs use in an OAuth world. And here's another picture similar to the one that Jonas spoke about. And so basically, APIs can issue security challenges. So you're probably all aware of things like expired access tokens, and you get a 401 status response, and the front end can do a refresh and that sort of thing. But sometimes you can do other use cases. We're going to show a demo later where you sort of allow people to onboard to your web applications without any complicated logins and get some frictionless initial access, and then APIs can ask for more security. So that's the concept of scope that Jonas was talking about, where the front end then has to guide the user and tell them to sort of now you've got to log in or something. And we'll show ways that you can vary that a bit later. But the important thing here is when these security challenges happen, that the front end has usability control, And so sometimes in older solutions, we saw the front end abruptly redirected, etc., and the user didn't quite know what was going on. These days, the front end should be able to control those kind of things. So
Right, it's kind of handling those things gracefully, right? It's taking these things, like, I mean, we can always view them as error responses, but it's taking them as instructions for what to do next, right?
yeah, absolutely, and there's very good reasons for them, because people don't always think of it this way, but 401s keep your API credentials, such as cookies, short-lived, and 403s keep the API credentials least privileged. So that hacker guy we showed earlier somehow got hold of a cookie or a token or something, there's less they can do with it than if the API credential enables all of the user's privileges. So that's an important thing to understand.
And
And
you will show that you had sort of the step-up authentication. You will show that in the demo later, right? So
we will do shortly, yes, indeed.
yeah.
So, and another point to understand is that those of you who've used technology stacks like React, the front end lays out a tree of views that can result in concurrent API requests after the page loads. And these concurrent API requests can experience these challenges potentially, especially when it comes to expiry, and so they can, synchronize things like token refresh. And again, the front end has that usability control. The front end doesn't get abruptly redirected. You can guide the user and give them a good experience. And usually, if a token expires or something, then the user doesn't notice anything. It's seamless for them, and that's typically what we want in a modern web app.
I mean, that's a critical part, I think, too.
Yeah.
The usability, or the user experience, is the critical part, right? It should, the front end there should handle that, like I said before, gracefully, or whichever terminology you want to use. It should handle it so that it's no friction for the user, right?
That's it. I think, these days, if you want people to use a security solution, that security solution should have good usability as well, because, it's a major concern these days. You're trying to, outperform your competitors, etc. So a good web solution these days in the API era can use the security best practices, the short-lived and least privileged API credentials, but also have slick usability. And one of the things OAuth does actually is enables all of the latest technologies, because OAuth is all kind of JSON-based technology. It works in any technology stack. So some of the older technology stacks for web applications, you don't necessarily need to use them anymore. A lot of people these days prefer the front-end only technology stacks that are where the developers spend all their time on the customer experience, and that's a good thing to aim for, I think. And another point worth mentioning is when front ends receive secure data, it's kind of nice to have the same architecture for web and mobile, so that you follow the same principles. I know there are some differences for web applications. Right, so Jonas, you're going to take us through some pain points because there are some older ways to do web applications that at first sight they seem very attractive, but when you get into the details, maybe that's not the case. So,
Right. I mean, there's obviously been ways to do this for a bit. There's been bad ways to do this for a long time too. There's several different approaches to this. Yeah, so let's look at some of them. There's also kind of, I wouldn't maybe say a lot, but there's definitely marketing out there that suggests solutions that are subpar as well, whether they're old or new technologies. But yeah.
okay, let's move on.
So yeah, choose your choose your BFF with care, which is kind of a funny title, but the the front end should maintain reliability and usability control, just like we said. There should be a focus there on usability, and it's easy to lose these sort of capabilities or focus when you integrate cookie security, as well as sort of understanding cookie security for a front-end developer sometimes. It's not necessarily super easy. So you can struggle with that for it could be complex to develop that kind of approach, right? And I'll talk a little bit more about the technology marketing because there's especially sort of, I think, solutions out there in the market that are kind of marketed as a quick and easy fix, which on the surface looks like a great approach because it is looking simple, but it doesn't always sort of um, provide that usability on the front end. It might be easy to put it in place, but that doesn't mean that it's going to end up being easy or a great experience for the user using the app, right? And so I think one particular that kind of falls in that bucket is the gateway approach, where you essentially put sort of a gateway in front of your application that handles the cookies. The problem here is we lose quite a bit of control, or we almost lose all of the control. It becomes more of a kind of a binary approach where if there's a cookie, we're good to go, and if there's not, we end up having this sort of abrupt redirect, which can mess up a lot of things. Like you can lose control over UX prompts and coordination across sort of multiple tabs in the browser, for example. Session refresh and things of that can will get messed up here, right?
And
So
sometimes I've seen some of these where, like, for example, you're forced to host your web and APIs in the same place where you may not want to. And I've even known things where the gateway passes through like a header or something to the APIs, and the API
yeah,
doesn't even receive a token and isn't really in charge of its authorization. I think we're going to list some
right.
here, aren't we? So,
And I think you also sort of lose one of the things we talked about before, like properly designed tokens, right? So in that sort of approach, you have cookies is the baseline of the security there, right? Where do we check sort of audience and scopes and context for the web application and things like that? Those are essentially kind of unknown, right? Um, and yeah, so
I think
we
another case here sometimes is you've got an API and then the API needs to call another API and then it's struggling because it doesn't have a token or something.
which happens a lot these days, right? We have microservices in the back end there that performs a lot of specialized tasks on their own, and we need tokens to flow around there. There shouldn't be one token that passes around to all of those backend APIs, right? There should be specifically narrowed scopes, access tokens in between those services and whatnot too. Um, this one is sort of interesting because it's we can already see from from this from this overview that there's a lot more complexity here, right? So we have a backend sort of component essentially that will handle a lot of these things on the back end, meaning that the front end application here doesn't really, I'm not going to say do much, but it doesn't handle a lot of the security mechanisms here. This also means that the front end doesn't really know how this is done and how it's what's happening. We can also see that there's a lot of complexity here, right? And with a lot of complexity, we run the risk of things going wrong, right?
Mm. Yeah, and it's so in some ways a front-end specialist developer needs to deal with more back-end concerns than perhaps he or she wants to. And I think one interesting point is the use of pre-rendering and server-side rendering, which I think works
Hmm.
fine, which works really well for unsecured data when you're trying to get good SEO and that sort of thing. Or if you want to pre-render a certain amount of labels and content, etc. I think that's fine, but we kind of believe at Curity that the web host should still remain fairly lightweight. And if you have to deal with if the web host comes into contact with data from APIs, then all of a sudden it needs to deal with cookie issuing runtimes and uh, getting cookies out of tokens, forwarding them, API routing, and the associated expiring error handling, etc. And some of the components you run in the web host may limit your web deployments. For example, it might be harder to use content delivery networks and things. So it's not necessarily less secure. It's a bit less, it works less well for people, we generally find. And coming back to one of the points we made earlier is if you get an HTML response with secure data and one of these challenges like a 401 or 4.3, the web developer's in less control. That with HTML response can either be a different page or a redirect or something. So imagine the cookie expires. The front end doesn't have too much control here. We can't inform the user your session is expired so easily. It
Right.
may still be possible, but generally it's more complex. So we think this one has um, some disadvantages that we list here.
Right. I mean, the complexity there kind of translates to time to market, right? It will take more time to manage that and get it up and running because it is more complex, right? Um, it also it kind of tightly coupled the front end to the back end there, right? Which could limit your deployment options and where and how where and how the back end is deployed limits your where your application can actually be served, right? And you could end up needing to deploy that backend in multiple different locations or geographical regions because of compliance regulations and whatnot, which further drives the complexity and time to market aspect, right? And you already mentioned the server side rendering there, I think a little bit, but like losing that control in the front end, it impacts things like, step up authentication, for example, that you're going to look at later. Kind of things like, if some things go wrong and like the ability to like retry something in the front end or kind of save a draft or things like that, spinners and whatnot. So yeah,
So we
it
often think that if you want to use like server side or pre-rendering of content, that's fine for unsecured data, but for secured data, it introduces these extra complexities. So we'd recommend that you consider getting your secured data from APIs rather than from a web host. We think it's a better pattern. So I'm going to talk a bit more about what a modern web security design looks like. And at Curity, uh, our main recommendation for current web security is called the token handler pattern for a lot of the reasons that we've spoken about. So first of all, on the left-hand side here, the front-end application can be like a pure React app or Next.js or whatever you prefer. Um, and it builds to static content that you deploy to a content delivery network if you want to. The browser-based app uses the strongest security in the browser with short-lived least privileged cookies and all of those browser protections that Jonas mentioned. And the token handler is essentially utility API components. They run on the API side of the architecture in a gateway and behind it. And it doesn't impact your API development either. What the token handler does is it takes the secure cookie, extracts the access token, and forwards it to APIs. So you've got the kind of productive setup where your front end specialists work on are focused on the front end, and the API developers are focused on using these scoped access tokens to apply data protections. So it very much simplifies a lot of the security for the teams. And the cookie layer is a bit of an awkward requirement for web applications, but we think this is the best way to handle it. So I'm going to show you a demo, and this is a demo app we've built, and it's not a real application, but we sort of want to show you the blend of security and user experience here. So I do this reasonably quickly. See if I can explain it. So here you go. It's called Market Buddy. It's a pretend application. So
We still see your presentation, Gary.
I'll do you really okay. So I'm not showing that probably.
While you're switching that to, I'll make a call out for our attendees here to drop some questions in the Q&A if you have them. We'll spend some time at the end answering your questions.
This is not so good. Do I stop sharing? I'll stop sharing this window. And that's what I want. And this is so I'll share Market Buddy this time. So here's our application.
There we go.
And it's like I said, it's a pretend application. And probably the first thing we thought about when we built this was, people often want a very quick onboarding experience, a frictionless first access, and you can do that in a couple of ways. So when we click launch, what we're doing is an automatic login here, and I mean we're considering this data, which is some stock prices for NVIDIA and various companies. It's probably gone up since we did this demo because all the AI work they do. But this is pretty public information, so therefore you don't need strong security to use it. So the idea is you can blend security with user experience. So the user gets into your application straight away, sees some value, can actually see these graphs and things, and then we can guide the user. And
so this is the example of that sort of less secure data that you mentioned, right? Underneath the hood here, we've already made an API call to an API with an access token, but you obviously didn't log in as a user. But there's some level of information that we can already get from our API.
Exactly. So there's a call here to the API, and if you look at you probably can't see this too well, but much bigger. I don't know, maybe can't see that because it's not the same window, but so this is actually using the latest, strongest cookies to call APIs, but the token doesn't have very high privileges. We have a graphic here that explains how if I look at the access token, there's not many scopes here, and there's not a level of assurance that the right user is present. And based on that, the API knows what's allowed and what's not allowed. And from the front end viewpoint, you can guide the user. So there's no abrupt redirects from the APIs. It can return a response, but that response is always received by JavaScript. So we can guide the user now and say, to do personalized things, sign in. So the next stage is to sort of design a fairly pain-free login. So in my example deployment, I'm just going to paste in an example email address. So any old email address. So this is a completely new user, and we're going to ask for the email, and then the user can log in by verifying the email, which any user knows how to do, I think. This is like a maldev test email inbox that enables you to get a one-time code as any test user, which is what I'm doing here. Oops. Paste. there you go. So it's still a fairly painless login. So we've sort of stepped up now to an authenticated user, but we don't know much about the user. But
Hmm.
what you'll see is we're sort
Yeah,
of,
I mean, at this point, we know the email address of the user, right? That's pretty much it. So we've captured something. We have a way to kind of
yeah.
connect with the user, but that's it.
Yeah, so we're leading up to allowing the user to buy stocks and shares is what is the theme of the application, I suppose. And before you can allow them to do trading, uh, we need to know more about them. They need to create an account and collect and know your customer information, that sort of thing. But the thing to notice is that the front end is guiding the user. And we're keeping, even though the login so far is not very, uh, it's not high security or anything.
Right.
It relates to the data that's being shown.
But but now with doing this, I mean, it's one level of step of authentication, right? So we have actually, because now we've actually authenticated as a user. So the assurance level in the tokens, we've actually received new tokens now, right? We
yeah,
have a higher assurance level in the token than what we did when we had no user at all.
that's it. So now we're doing the higher security stuff, and we're going to ask the user to create an account. And this kind of asking the user to create an account, this kind of onboarding stuff, you can do it in your authorization server. So I'm using the security identity server here, and this is a different domain to the web application. And I've customized this screen to make up a user called John Doe and make up date of birth. So we've collected some custom information from the user, all of the legal terms to use our application and stuff. You can do that at this stage as well. And then the user agrees to the terms of service and continues. And often what you do here is you might implement some high security form of authentication or something. The user might present a stronger credential or something if you need that. So obviously the authorization service specializes in that sort of thing. Any built-in or custom authentication method you could use here to create the account. So at that point, you've got a much higher assurance of the user's identity. And the final thing, because we wanted to build this in stages, is the user can see stocks now. They've got a high privilege token. They could register an intent to buy stocks or something. But to actually do the buying and selling, they need to upgrade to strong authentication. So when I click this, again, we guide the user, even though I received a 403 from the API when I did this, 403 step-up response. I can now come along here and we're going to use a strong form of authentication called passkeys. So the way that works is we create a passkey. You have to touch my book thing, and you see it's quite relatively simple to use. And now the user has a more complete level of access. And so the data is now properly protected. And of course, the way that we're showing this, you could invent your own solutions for the strongest security and stuff. But the thing to notice is the front end is in control. There's none of these abrupt redirects or anything. The API very much drives the security, and the front end has the usability control to deal with it. Finally, let's do a logout. And at this point, the user is fully onboarded and can do the buying and selling and stuff. And so when I sign in, all subsequent logins, I just sign in with the passkey I created, which is just a touch. And behind the scenes, passkeys use, they send a very strong cryptographic signature to the server to prove that it's the same person as last time. So that's a strong form of security. So that was a demo we wanted to do.
Well, that's like it's multiple step ups
Yeah,
along the way in the initial flow there, which is like capturing the user uh, journey type of.
absolutely. So hopefully that helps to sort of put together some of the things we were talking about. So what that application showed you was, right, if I share my window again, so hopefully we're back. So that all visible now, Jonas, I hope.
Yeah, I can see your
Right,
the
so
demo slide.
if we go back at some of this, so if you look at how that app is built, the front end is a single page app, a React app. When you build it, it produces static content that you can deploy it separately to your APIs. It uses all of the latest security. So the cookies are short-lived and least privilege, and they step up as we go along. And I suppose the end result really is that because the security is designed by Curity, and we're very up to date with the latest security best practices. Um, uh, all of the browser best practices from the document, the OAuth 2.0 for browser-based apps document that Jonas mentioned are handled for you. Like I say, the security is on par with hardened websites. And I think a lot of websites use older technology actually, so they're probably less secure. There are newer OAuth flows you can potentially use, like pushed authorization requests have reduced the possibility for changed requests in the browser and stuff like that.
Right. You can essentially leverage FOPI, right? Like, I mean, financial grade API security in this too.
Absolutely. So, you can use all of those options on the server. The browser is a more limited environment, so all you can do in the browser is follow the current best practices. And it's quite important as well, if you ever has to go under security reviews or whatever. Um, uh, I think browser security has always been a hot topic, so being secure in the browser, being aware of the best practices is important. So, like I say,
And so in this case, the token handler essentially takes care of the cookie. I mean, here we say no cookie code, but it's because the token handler handles that, right? So
that's it.
the web developer doesn't really need to worry about it, and the API developer also doesn't need to worry about it because the API developer only operates with tokens because that's all the API will see.
That's it. And like I say, so there's a few ingredients here. One is the productive developer experience. The other is the high performance deployments that people should think about. The other is the separation of concerns to reduce responsibilities for web and API developers. And the other is those API challenges and the usability and reliability control. And if you get on top of those, you
Right.
get a great modern architecture, we think, that ticks all the boxes really, So
And removes a lot of complexity. I mean, it
yeah,
is a backend for front end component, but it's super lightweight, right? So it's simple, which then removes the complexity, which sort of it translates to time to market again, right? And
exactly. And
yeah,
sometimes people they get their cookie solutions partially right, and then they run into some of these usability and reliability issues, and then they're very hard to solve because the core behaviors of the technology stack or whatever don't really deal with it very well. So sometimes you think you're close to release, and you have
yep.
to release with issues or delay your release. Um, so that's the demo.
Cool.
So I think with the token handler pattern, essentially you need to do some deployment work to get these endpoints in place. But uh, once you've done it once, then for all future work, you should be more productive. That's what we hope.
But it's also fairly I mean, it's easy to be biased when you've worked with it, I guess, but it's fairly simple and clear-cut APIs that you need to call on the token handler, right? So even though, yeah, there is some work, but it's fairly light work that you need to do to integrate that. Um, on that note, we do have a question if the source code is available for that demo application.
Uh,
And I don't think it is, but there not that specific one, but there is source code available for another sample single page app which uses the token handler. There's a whole project, in fact, available that will host up um, a web application, an API, an API gateway, the token handler, and all of that. So we can I can find it and paste a link here in the
I think
answers to that too.
I think we will release this, and essentially it's just if you can imagine in the APIs, it's very similar to the existing code example. It calls those endpoints, and then it
Yeah.
looks at the status codes. And what we did for this application is that we put some states in the ID token, and so really the only thing the web app needs to do is to look at those states in the ID token and decide what to render and how to guide the user. So I think really probably the simpler thing to look at if you're not used to the token handler pattern is the default example we provide. And then once you understand that, I think it's quite easy to see how the ID token could have some states like has account, has MFA. And based on those states, the front end can guide the user, you know? So that's it.
Yeah, I mean, there's nothing secret in this in this demo application. It's just that we haven't released it because I don't think that this specific demo that Gary used here is not it doesn't come as a complete project, whereas the other one is a complete project with all of the components. You basically run Docker Compose up, and then you have everything that's needed to run it. So that other one is a good start because it's already available, but we'll probably make this one available too.
I think so, yeah. I think we'll do a bit more detail on step-up authentication because this was quite an
Yep.
interesting project that we did earlier in the year to make us think more about how to get people to understand modern web applications, actually, and the things we've been speaking about today.
Another question I'll pose for you here, Gary, is the token handler pattern also usable in third-party consumer situations?
Sure, I think we need a bit more kind of detail. So that's essentially where the way the token handler pattern works is that wherever you host your web content, which might be www.example.com, then you have a parallel. Well, I think if you want to separate the concerns, as we've been talking about, then you would host the cookie issuing endpoints at maybe api.example.com or bff.example.com, and it's a domain, a sort of a sibling domain in the same site as as the web static content. And these days you can do things like, for example, in AWS, you can use AWS CloudFront for one of those subdomains, the web one, and you can use, for example, Elastic Kubernetes service via APIs, or that's one possibility, or serverless APIs if you want to. So, so using the same kind of subdomains, you can map them to, for example, in AWS, you can use Route 53 to that. So in a third-party consumer situation, you still need to ensure that the browser talks to gets its cookies from a domain in the same parent site. So essentially, the cookies we're using here are they need to be first party. So you can't call across completely unrelated domains using cookies these days because the browser will drop them due to user privacy restrictions that have been built into browsers.
Um, Thanks for that. Another question: how do I use the token handler pattern for multiple web applications?
I think that's an interesting question, isn't it? So I think that essentially, whenever you use cookies, you need to think about your deployment and domains. So there's two main models really. One is to use distinct domains because distinct domains ensures cookie isolation, and that's probably the best default option so that a high security app can't be impacted by a low security app. So just keep the domains separate. But there is another pattern called like micro front ends where sometimes you've got a single app and we split it in for code size reasons, perhaps, so you've got a web app, it's getting quite large and you split it into app one and app two, and you can run those apps at the same path. Sorry, at different paths within the same domain. So that's another deployment option. But you need to be careful that you're not crossing security boundaries, that's all. So when you do cross those security boundaries and you've got a low security app and a high security app, then a better choice is to have different domains.
Right. And on the token handler side, obviously, you need to have sort of different ability to have different configurations and settings, right? Because one application might not have the same requirements as another application. There might be different requirements on sort of token time to lives and things of that nature. I mean, one app might need and require FOPI and another one doesn't, for example. There might be a whole slew of different requirements for the different applications. So,
That's it. So
yep.
essentially, I think if you look at the way that we deploy this, so that complexity in the web backend that Jonas showed you earlier in the slide with all of the complexity the web developer had to deal with, is essentially implementing that as utility APIs and just deploying them behind an API gateway. So you deploy them get it reliable, and then you very rarely need to change that stuff afterwards. It's just there, and so each application, rather than having a complex web host that gets in the way of development and deployment, you can just deploy utility APIs instead. And these days, organizations often have a lot of existing APIs anyway, so they know how to deploy APIs.
So that's it for the questions. If you have a last minute one, feel free to drop it in there. But otherwise, you can also find us on these resources, security.io. Feel free to, if you have a question after the fact here at info@security.io, we have a couple of links there to token handler resources. Go find those. So I would like to thank everyone for listening into this webinar. Thanks, Gary. It was a good conversation here, and we'll see you at the next one.
Thank you.